All right, welcome back to our final video on worksheet one. This is just covering distance, rate, and time problems. And in this video, we'll cover 7C. So let's take a look at 7C. It says a car passes a highway landmark at 55 kilometers per hour. 1 hour later, a second car passes the same landmark in the same direction at 90 kilometers per hour. How many hours after the second car passes will it overtake the first car? And how far from the landmark do they meet? Okay. Um, how far from the landmark do they meet? Okay. Let's take a look. Um, so we have a landmark. I'm just, this little building, call it L. And there is a car that is passing the landmark initially. We'll call that car one. Okay, and they're traveling in the same direction. So let's go ahead and draw the picture there for just a moment. What we know is that the first car passes at 55 kilometers per hour. Okay. And then 1 hour later, what happens? 1 hour later, a second car passes the landmark. So 1 hour later, this first car is, making its way along in that direction. And the second car is now passing the landmark. Okay, we'll call this car 2, heading in the exact same direction, assuming on the same road. Now, this second car is traveling at 90 kilometers per hour. It's traveling faster than the first car. Okay, so how many hours after the second car passes will it overtake the first car? And so what we want to know is how much time will it take um, for, let's say, yeah, for this second car, since it's traveling faster, it's eventually going to catch up to the first car. So eventually it will be, they will be lined up, right? Car two is going to overtake car one. At that moment, they will be exactly the same distance from the landmark. Okay, so um, let's take a look then. Let's describe the the distance here. There's going to be some distance from the landmark at which they meet. That distance will be the same for both of them because um, we're using as our point of reference the landmark. Now, how much time? This is the other part that we need to kind of pay close attention to. This distance is going to be the same, but how much time is each of the vehicles going to travel? For how much traveling time will pass for each of the vehicles when car two overtakes car one? Let's go ahead and set up our table so we can kind of organize our thoughts. Okay, so we have our name column. We have distance, rate, and time. And so we usually have the name here, we'll just say car one, car two, and then we have a total category in case we need it. So a couple of things that we know for sure is car one is going 55 kilometers per hour. Kilometers per hour. The time is going to be in hours. And then when you multiply those two, you have distance in kilometers. Okay, so we have 55 kilometers per hour. Let me write that in black. The faster car is going 90 kilometers per hour. And now let's go ahead and move on to the time that they've been traveling. This is actually one of the variables that we're going to assign because, as I said in the previous video, the question is how many hours after the second car passes will it overtake the first car? So what we want to know is how much time does the second car travel until it catches up to the first car? So the time is starting after the second car passes the landmark. It says how many hours after the second car passes the landmark will it overtake the first car? And so how much time is passing? Well, that's where we can assign our variable, and we'll just call it, let's give it a variable x. Okay. And so now for car one, how much time has passed? How much time passes? How much time does car one travel until it gets overtaken by car two? So think about that for a moment. How much time does car one travel until it gets overtaken by car two? And so essentially, we're asking the amount of time, I'll write here in red, the time for car two, we've defined to be x. Now, how much time did it take for car one to travel this exact same amount of distance? The time is not going to be the same. The time for car two, hopefully you thought about it for a moment. Time for car two, we said was x. The time for car one is 1 more hour, x plus 1. Because remember, for car 1 to get this distance away from the landmark took 1 more hour than what it took car 2. Because remember, car 1 passed the landmark, and then 1 hour later, car 2 started passing the landmark, and that's where the timer started for car 2. Car 1 had already been traveling for 1 hour at the time that so car one, actually, I drew it in my picture. Car one's time was 1 hour at the moment that car two was passing the landmark. So here we were 1 hour in. Then it takes X hours for car two to catch up. Well, then those X hours are also added onto car one's time. So giving us a total of X plus 1 hours of travel time for car one. Okay, so we'll put x plus 1 here. Now we can use our equation, distance equals rate times time, to find an expression for the distance traveled from each of the cars. So that would be 90 times x for car 2. We just multiply here, distance, rate and time. And then 55 times x plus 1. That's the distance that uh, car 1 travels. And in this case, we're not going to need this total row here. I always like to write it just in case we need it, but you have to really think critically about this. Are we adding up the times that they traveled? No, we're not. I mean, we don't need to. And then are we adding the distances that they travel? No, we don't need to do that either. So where's our equation going to come from? Well, if you remember the clue that was given here, car 2 is overtaking car 1. We actually said it earlier, but these two distances should be equal. I wrote the line in black right here. The distance from car 1 to the landmark is the same as the distance from car 2 to the landmark when car 2 is overtaking car 1. They're the same distance from the landmark. And so these two distances here, um, distance of car 1 from the landmark L is equal to the distance of car 2 from the landmark L. Okay, and so that gives us the equation 55 times x plus 1 equals 90x. And so now we can solve this equation. Let's see, I don't want to go into the second page if I don't have to, since we're almost done. So let's go ahead and try to solve this equation. This one is not too bad. We can distribute, and we have 55x plus 55 equals 90x. If we subtract 55x, then we have 55 equals, what is this, 35? And so now we can divide by 35 on both sides. We can reduce. Both of these numbers are divisible by 5. So we divide by 5 on the top and the bottom. And so we end up with 11 over 7 equals x. And x was defined to be, if we look at our definition, the way that we defined x, if you use this table, it's pretty clear. X is in the time category for car 2. So this is the amount of time that car 2 traveled until it caught up to car 1. Okay, and so this is a time in hours. X is equal to 11 over 7 hours. You can write it just like that. That would be acceptable here as an answer, since we don't have calculators on the quizzes. But if you want to approximate it, just for the sake of knowing, 11 over 7 is approximately 1.57 14 hours. It does continue. Now, if you wanted to check this, suppose you wanted to check your answer, you could just find out, well, how much, how much distance do each of the cars travel in this amount of time? Oh, when x is equal to 11 over 7. Um, so, um, well, you can find that out. I'll write it here very quickly. Let's see if we can do it without a calculator. 90x is the amount of distance that car 2 travels. So 90 times 11 over 7, that is going to be 90 times 11 over 7. Is 90 divisible by 7? No, it isn't. So we can just multiply 90 over 1 times 11 over 7. That is 990 over 7. And this would be in miles. Now, I don't know what that is. That's the distance that, I don't know what that is as a decimal. I can't divide that in my head. But this is the distance for car 2. Now we can check car 1 just as quickly. 55 times x plus 1 was the expression. And so we know what x is. Let's plug it in. 55 times 11 over 7 plus 1. Instead of putting 1, let's go ahead and put not 1, but 7 over 7, just to kind of get a common denominator to be able to add those two. And so we get 55 times 18 over 7. Is this the same thing as 990 over 7? Um, yes, because 55 times 18 is 2 times 9, and 55 times 2 is 110 times 9 over 7. We only multiply the 2 by the 55, not the 9. And so now you can see, well, 110 times 9 is 990 over 7. And so what this serves to check here, this is the distance traveled by car 1. If x was equal to 11 over 7, well, car 1 and car 2 traveled the same amount of time. That means car 2 is overtaking car 1 at this time. And that's exactly the situation that was given to us in the problem. So, this is the correct answer. So, to give our sentence answer, car 2 travels 11 over 7 hours until it overtakes car 1. Okay. And that's it. All right. Thanks for watching. Make sure to leave a like on the video and leave a comment if you have any suggestions. And if you like the video, I'll keep making more. All right, well, we'll see you in the next one.